So we need to determine the first four terms of the Maclaurin series for sine of 2x. In part A, we need to do it by using the definition of Maclaurin series. In part B, we need to do it by replacing x by 2x in the series for sine of x. And in part C, we need to do it by multiplying 2 by the series for sine of x by the series for cosine of x. Because sine of 2x equals 2 times sine of x times cosine of x. Well, let's start with part A. So in part A, we will use the definition of Maclaurin series. And we start by calculating the derivative for f of x equals sine of 2x, and the value for the derivative still 8th order. So f of x equals sine of 2x, then f prime of x equals 2 times cosine of 2x, then the second order derivative of f of x equals negative 4 times sine of 2x, then the third order derivative of f of x equals negative 8 times cosine of 2x, then the fourth order derivative of f of x equals 16 times sine of 2x. Then the fifth order derivative of f of x equals 32 times cosine of 2x. The sixth order derivative of f of x equals negative 64 times sine of 2x. And the seventh order derivative of f of x equals negative 128 times cosine of 2x. And the eighth order derivative of the f of x equals 256 times sine of 2x. Well, now we need to calculate the value of this derivative at x equals 0. So f of 0 equals 0. F prime of 0 equals 2. The second order derivative of f of 0 equals 0. The third order derivative of f of 0 equals negative 8. The fourth order derivative of f of 0 equals 0. The fifth order derivative of f of 0 equals 32. The sixth order derivative of f of 0 equals 0. And the seventh order derivative of f of 0 equals negative 128. And the eighth order derivative of f of 0 equals 0. Well, now let's use these values in order to expand our function using the Maclaurin series. So for Maclaurin series expansion, we get that f of x equals f of 0 plus f prime of 0 times x over 1 factorial plus the second order derivative of f of 0 times x squared over 2 factorial plus the third order derivative of f of 0 times x cubed over 3 factorial plus the fourth order derivative of f of 0 times x to the fourth power over 4 factorial plus the fifth order derivative of f of 0 times x to the fifth power over 5 factorial plus the sixth order derivative of f of 0 times x to the sixth power over 6 factorial plus the seventh order derivative of f of 0 times x to the seventh power over 7 factorial plus plus the eighth order derivative of f of 0 times x to the 8th power over 8 factorial, and so on. Then this equals, we will substitute the values of derivatives at x equals 0 into this expression, and we get that this equals 0 plus 2x over 1 plus negative 8x cubed over 3 factorial plus 32x to the 5th power over 5 factorial plus negative 128x to the 7th power over 7 factorial, and this equals 2x minus 4x cubed over 3 plus 4 over 15 times x to the 5th power minus 8 over 315 times x to the 7th power. So this is our final answer for part A. So sine of 2x equals this. Let me highlight this here. Well, now let's do part B. Here we need to replace x by 2x, and you evaluate the series for sine of 4x. So sine of 2x equals, again, I'll just copy paste this expression one more time. So equals this expression which we have just found. Then if you want to find sine of 4x, we just replace x with 2x. So sine of 4x equals 2 times 2x minus 4 times 2x cubed over 3 plus 4 over 15 times 2x to the 5th power minus 8 over 315 times 2x to the 7th power, and this equals 4x minus 32x cubed over 3 plus 128x to the 5th power over 15 minus 124x to the 7th power over 315. And this is our expression for sine of 4x. Now let's do part C. We need to determine the product for the two Maclaurin series for sine x and cosine x, and compare it with the Maclaurin series for sine of 2x. Well, the series is same for both expressions, so sine of x equals x minus x cubed over 6 plus x to the 5th power over 120 minus x to the 7th power over 5040. And cosine of x equals 1 minus x squared over 2 plus x to the 4th power over 24 minus x to the 6th power over 720. Then 2 times sine x times cosine of x equals 2 times x, I'll just copy paste, times this expression, and wait. And times this expression. Great. Well, if we do multiplication, we get that this equals 2 times x minus 2x cubed over 3 plus 2x to the 5th power over 15 minus 4x to the 7th power over 315. Then this equals 2x minus 4x cubed over 3 plus 4x to the 5th power over 15 minus 8x to the 7th power over 315. And this is our final answer.